So let's start by creating a quad for our player. So 3D object quad, and let's name this player. Now let's just remove the mesh collider as we are dealing in 2D. So let's include a box collider 2D instead, and let's just increase our Y scale by 2 so that it resembles a player. And while we are at it, let's just change our camera background to black because I prefer it. And now let's create a folder to store all our player components. Let's start by giving a material to our player. We'll name it player as well, and let's give it a unlit color shader. Let's change the color to something desirable. Let's go with a dark shade of purple, and let's just drag it into our player game object. So now let's just bring our player in front of the camera. So decrease the Y position to 0. And now let's start by creating a few scripts. So the first one we'll call it player movement. And now let's create another script. We'll call this one controller 2D. And the third one we'll call this player attribute. So this will store all our player stats and parameters we need for the player to move and interact in general. And let's create a folder for our controller because it's not exclusive to our player. And let's drag our controller script in here, and also let's create a raycast controller 2D which will work alongside our controller. Basically controller would inherit from the raycast to get raycasting data from it. And let's also create our player manager folder and store our player manager script which is responsible for managing players, more than one players if we were to our game, and also handle all our events from the player input. So let's also go ahead and create our player input script. So let's open our project settings and head on to input manager, and let's focus our attention to the first two inputs, horizontal and vertical. So this is what will allow our player to move in the X and the Y axis. So let's just copy the names because we would need it later. So why I segregated the components based on our game objects is because we can always filter our components as scripts or prefabs or materials by clicking on this icon right here, and we can choose what components we want. So let me click on scripts, and now all our scripts are in one single place, and let's just open them in Visual Studio. Go to player input.cs. So here in the update method, let's make use of our horizontal and vertical input. So I'll create a vector tool called directional input, and let's pass in our input as a raw axis into our vector. So the first being horizontal and then our vertical in the Y parameter. Let's just move our player input to the right, bring up our player manager. So what we are going to do is make use of delegates. So I'll start by creating a delegate outside our class, and it will of course be public, and we'll call it directional input, which takes in an input parameter of type vector2, and we can get rid of our default methods for now. So we'll start by creating a few events, and this will reference our delegates. And let's also create a method. So we'll call this execute directional user input, and it will take in an input parameter of type vector2, which will in turn call our event on directional input, which as you know references directional input delegate which needs a parameter input. So we'll also give our event that parameter. And now what we can do is, since our method in the player manager is a static method, we can simply type the player manager class name dot the method name, that is execute directional user input, and pass in our directional input that we are getting from our input manager. And this will in turn send our input parameter to our event which has a reference to our delegate. And why we do this will be making sense later on when we actually start writing our player movement code. So if I just jump on to our player movement.cs, remove the default methods, and let's create a method on enable. So this is a inbuilt Unity method which triggers when our script component is enabled. So on enable we can subscribe to our event. So a method named set directional input will be subscribing to our player manager event. So we don't have that method yet, so let's just create it. And as you can see, since it's subscribed to a event which needs a parameter of type vector2. Even our newly created method by Visual Studio requires a parameter of type vector2. Let's remove the throw statement, and for now let's print our input to check if it is working as expected. So debug.log will print our input x value first and followed by y value. So now let's head back into Unity and create a player manager game object and include our player manager script, also our player input script, and in our player game object we'll include our player movement script. And now as you can see, we are receiving our input every frame, and if we were to press any of our movement controls, that is the arrow keys or the WASD keys, where A is the negative value of x axis and D would map to our positive value. Similarly, W will map to our positive value on the y-axis and S would map to the negative. And for the arrow keys also, it will function the same way. And you can see we can make a combination of values on both the axes, which will also help us point to a diagonal direction. So that's working perfect. So next what we can do is let's open up our input manager again, and now we can focus on our jump input parameter as you can see here. So let's just copy that name and go back to our code, and here in the player input.cs let's get another raw axis and we'll pass in our jump input in the if condition being that it is not equal to 0, that is it is being pressed by the player. So when our jump input is pressed, we can call in our jump event. So let's just make that. So back again in input, or rather player manager, we'll create another delegate jump input down and a matching event for that. We'll call this on jump input down, and now a matching method to that, and we'll call this execute jump input down user. So since we are not passing two values, that is our x and y, like we had done previously for our movement method, we don't need to give it a parameter, and let's just call our event inside this method. And let me open up my player movement.cs, and here on enable again we can subscribe to our player manager event. And now to create that method, again let's remove our default throw statement and put in a debug log statement. For now we'll just say jump trigger. So let me just bring my player movement script to the bottom and keep my player manager script on top. So while we are enabling our methods to subscribe to the player manager events on enable, let's also disable them when our player manager or rather our player movement is disabled. So let's add minus equal to instead of plus, and that's how you can unsubscribe from a event call. And let's go back to our player input.cs and call our player manager method on jump. So when the user press spacebar, this piece of code here will trigger and it will call our player manager method, which in turn triggers our jump event, and our jump event has been subscribed to by our player movement class, and it calls our on jump input down method on the class, and this would trigger our jump logic. So as you can see here in the console, when I press spacebar, our jump triggered logic is triggered, and we can see our log statement. So now suppose we have multiple players in our game. So how would our logic handle that? And we just can't tag them separately to differentiate them or put them in separate layers, because all of them are essentially players and our script should treat them the same. But then we need a unique identifier to differentiate among our various players. So for that, if I would just go to the setting on our inspector and change this to debug, as you can see all our components now display an instance ID, and in fact this instance ID is unique to each and every component. So we now have a unique identifier, not for the component, or sorry, rather not for the game objects, but for our component. But we know that every game object has to have at least one component, and that component is our transform component, because in order to exist in our game, every game object needs to have a position, scale, and certain amount of rotation. That's why let's take our transform component's unique ID, that is the instance ID, to differentiate our players. So let's just head back to our script. We'll open our player attribute.cs. We'll make a public structure called player info, which will essentially hold our player parameters. For now, let's create an attribute instance ID of type integer, and let's reference our structure in the same class. We'll define it as public player info. We'll call this pi for now. And let's also add a constructor for our structure. So this would take in an instance ID, and let's just link it to our instance ID attribute inside the struct. So now on awake, that is the very moment when our game begins and our scripts are loaded. So when our player attribute script gets loaded, we want to instantiate our player info reference, and we'll pass in our instance ID. So transform dot get instance ID would provide us that. So because we have used our transform value, that means even our player in attribute script needs to reside in our game object, our player game object. So before we jump back into Unity, let's just open our player managers and create a dictionary, make it static, and this will store all our player instance. So the key is of type int because our instance ID is of type int, and our value is of type player attribute because that's what we are going to. So instead of the structure player info, we are storing our enclosing class, that is player attribute, because that, as you know, is a value type, and every time we would call it, it would copy the value instead of pointing to a reference, and we don't need that because we want to have the reference so that we can push values back into our struct and into the variable or other value attributes that it holds. So let's just convert this property, and in our player attribute class on away, let's just call this dictionary property and add in our instance as well as value. So since player attribute script would reside in our player object itself, let's just pass in this. So that means our object reference of player attribute class. Back in our player movement.cs on awake, we would like to get our player instance from the dictionary, that is in player manager. So let's create a player attribute variable, and on awake we can make a check for our instance in the dictionary. So we'll write player manager dot player index dot contains key. Let's pass in our instance ID from the transform component, and also let's just check the instance ID in the player info instance. So we'll go inside our player attributes value. So player manager dot player index, let's pass in our instance ID again, and dot pi, which is our player info public variable, and dot instance ID. Let's match it with our instance ID from the transform, and these two statements should be enough to verify that we actually have got our instance correctly. And now let's just fetch that player attribute instance, and we can print a log statement. So debug.log got player game object dot name, and let's just end with instance. So let's just head back into Unity and let us add the player attributes component to all our player objects. Let's play and check our result. So as you can see, we are able to get all our player instances, and in that way we are also able to access our player info struct. So accessing that struct would be quite useful later on as we progress, as we plan to include all our parameters in player info. So back in player manager.cs, let's create an interaction method, and this is basically a method which would fetch our player instance. So let's write public static void get player instance, and now that we know that our player instance code is working, let's remove it from player movement and include it here, because we would not like to expose our player index dictionary. So instead, other classes can make use of this method to retrieve player attribute. So let's provide an instance ID parameter which other classes can send here, and let's also rename all the places where we need this instance ID. change the return type to player attributes, and inside the statement we can return our player attribute value from the dictionary. Let's remove the debug statement and put it back in our player movement and get rid of this line. Let's open player attributes.cs and we can create a new player movement variable in our structure, and let's also initialize it. So in player movement we can use our newly created method getPlayerInstance to fetch our player attributes instead. And let's make use of a null check to print our debug statement. So now below the debug statement, since we got our instance, we can pass in our player movement script to our player movement structure variable. So let's head back to Unity and test this out. So as you can see, we still get our player instances in all the three player game objects. So this is working. Let me just comment out our old log statement, and back in player movement, let's just add an additional log statement. Player movement instance, let's pass in our instance, is stored in player info. So now that we have our foundational code set up, I think this is a good point to end the video. In the next video, we'll actually start working on moving our player and we'll dive into raycasting. So until then, goodbye.